simple accelerometer is a container with air and water, because solids, liquids, and gas will always displace under conditions of acceleration or when there is a force present. The water will always appear to move towards the back of the container and push the air towards the front. In other words, the air will always get pushed in the direction of acceleration 100% of the time. When we're observing objects appear to move in a particular direction, vision alone is not a physical measurement of acceleration. For example, when I have a ruler going through a box, whether I move the box or whether I move the ruler is always going to appear to move because the camera is connected to the box. Unless we can observe it from the outside, the ruler will always appear to move. However, if I was to attach a simple accelerometer to the ruler, then we will know if it's the ruler moving or the reference frame without having to observe it from the outside. Which ruler would you bet is the one accelerating? 1 or 2? So when we're talking about downwards acceleration, which bottle will you bet is the one accelerating? 1 or 2?
What you see here is as Andrew lets it go, the separation of the gas, the liquid and the solid is halted until the stretch of the bungee cord is felt, and then the motion again ensues once connected again with the earth. In this scenario, the only force that's present is the tension of the spring. So buoyancy here stretches the spring to the top, and as the object is let go, the cylinder, you see that the buoyant effect no longer is at play, because the compression of the fluid forcing the ping pong ball upwards is no longer felt, and the spring then contracts back to its original position. Again, in this scenario, as Andrew actually accelerates upwards, we can see buoyancy, the effect, increase, that being that the ping pong ball now stretches the spring further. Another interesting thing to note here, as Andrew actually accelerates downwards, we get an inversion of what we call buoyancy and density. So we see the air now travel in the direction of acceleration, which is towards the floor. What you will notice is that the bubble has a flat bottom relative to its direction. When it's going upwards towards the sky, you will also see a flat bottom. In this scenario, you see it flattens out on the bottom, going towards the earth. again we see here the direction of the flame, the compression of air going towards the direction of travel. In this case, acceleration down, the flame inverts and goes the opposite direction. Interestingly enough, not in this little clip video here, but if you accelerate to up the way, adding to that motion, the flame will increase, the flame will stretch. Again, a favourite of people in regards to helium balloons and the likes. We see obviously helium wants to go upwards because the compression of air forces it in the direction of travel. As we put the system into free fall, helium then has no orientation, there is no compression of the air surrounding the balloon, so it has nowhere to go, it remains exactly where it is. And as we see the impact at the bottom, you can see that thrust, that initial push, you see the helium balloon immediately feel the compression of the air surrounding it and shooting towards the sky.